Hello. Happy Tuesday. Um, Here's your bell ringer question. You're going to tell me what you notice about all these numbers, and then what do these numbers tell us? So it says up here ACT scores and percentiles. And let me put this out of the way. And so this means if you get a 23 on the English portion of your ACT, then you are in the 71st percentile, which means 71% of people did as good as you or worse. That puts you in the top 29%. Top 30% of people who took the math test and got a 23. Top 44% of people who took the reading and got a 23. 29% who took the science and got a 23. Top 30% of people who took the overall test got a 23 overall. That puts you in the top 30%, top one third of people almost. And so what this does is it tells you a little bit of information about each score. Like if you get a 17, that means more than half the people did better than you that took that test in math, in English. If we look at the overall score, if you get a 17 on the ACT, that means that you are in the bottom 35% of people who took that test. Okay. And of course, that's not our goal. Of course, our goal is to do better and be extra awesome and learn, which is why we do all the ACT questions in our class and why I suggest all the time that you take it again. Because most people, just by taking it again, they raise their score by 1 or 2 points. If you take it again and study, you might raise your score by 3 or 4. All right. Now, when it comes to percentiles, like we were just talking about here, percentiles, right? This is like the most applicable thing for parents and students to understand. Like it's one of the most important things. These things get thrown at you all the time. Here's examples in my life. So, this is an actual piece of paper that was sent to me from the state about one of my own children and their scores um, on a test. And it says in that reading test, whatever state test it was, they took a reading test, they scored in the 85th percentile. That means that they did as good or better than 85% of people who took the test. That puts them in the top 15%. In math, this, I don't remember which kid this was, they got the 74th percentile. Okay. And then it tells me what to do to help them. Um, Here's another graph, although you can't see it. Let me see if I can fix that real quick. Let me put this in the back instead of in the front. So let's try that again. Oops, wrong button. Stop. Here we go. So this is one of my kids, and they were growing. I don't remember if it was one of my boys or my daughter, but this talks about how old they are and the average growth range. And this is my specific kid, right? So my specific kid was here, and then they jumped up to like the 88th percentile. Okay. And this is another one of my kids. Different. Oh, same kid, but this time it was about BMI, body mass index. So their weight compared to how tall they are, and it was getting higher and higher. And another one, a math score test where they're telling me the range of the percentile range. I mean, it comes all the time. So it's important for you to be able to understand percentiles and other aisles. They call them fractiles, like fractions, and how to use them and find them on specific data. And then we're also going to figure out a standard Z score and what that means. So in your notes that hopefully somebody has given to you, guided notes. If not, you can absolutely just use a piece of paper, right? Quartile, these are different types of fractiles. Quartile sounds like quarters, like we talked about yesterday, and it divides your data into 4 equal parts. Q1, Q2, and Q3 are the symbols for it. Deciles, like decimal, divides your data into 10 equal parts, and we call it D1, D2, D3, all the way up to D9. Percentiles divides your data into 100 equal parts. Percent means divide by 100. So it goes from P1 all the way up to P99. Okay. Now, how to calculate a percentile? You take the number of data entries that are less than that number divided by the total number of data entries. And then times 100 gives you the percent version. So the percentile. So let's do an example of that. Here's that formula again. A class of 20 students earned the following scores on their most recent test from 75 to 90. What is the percentile that matches a score of 84? Okay, so we need to know where that is in this list, 84. Okay, so where is the 84? There it is. I know these count too, but we're going to start at this guy. Okay. We're going to take the biggest 84 because all this stuff talks about as how many people did an 84 or less. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people got an 84 or less, right? So it says the number of data entries less than that divided by the number of data entries. So 12, we counted all the way up to 12 out of the total 20 people. And that'll give us a decimal and you multiply it by 100 to get the percentile. So that gives us 60 percentile. And so the test score of an 84 represents the 60th percentile. So another way to say that is that if you get an 84, that you did better or the same as 60% of people who took that test. You did better or the same as 60% of people who took that test. Now, there's a second part of this question. What score represents the 90th percentile? So this time they're not asking about 90. They're not asking about a score of 90. They're saying which one of these scores puts you in the top, in the top of your class here. 90th percentile means the top 10%. Okay. Top 10%, bottom 90, top 10. So we're going to have to do a little bit differently. We're going to have to say 90 equals I don't know what out of 20. We don't know how many data entries are less than that, but we want it to equal 90. It's kind of like we're starting at this P and we're going backwards. So we got to get rid of this 100 over 20. Um, so we're going to flip it and multiply. But the bottom line is you do 20 divided by 100 and multiply it by 90th percentile. And that gives you 18. So the number in the 18 out of 20 spots is the 90th percentile, which makes sense. 18 out of 20 is the same as 90 out of 100. So we're going to look on here. Okay, we're going to count all the way up to the 18th spot. So these are the 18. So 18 looks like the 18th spot is a score of 88. So there are 18 scores to get to the 90th percentile. So a score of 88 represents 90th percentile. So this time we got which spot it is. The X means the spot. X marks the spot. And it gave us 18 spot. And in that 18 spot was 88 score. Okay. So now the next topic on here is a standard score. And basically all this is saying is it represents how far away a specific piece of data is from the average or the mean, right? So we're looking how far off is it from the average? And this is the formula, and we'll talk about how to do that and what it means. So here's an example, finding z-score. The mean speed of vehicles along a stretch of the highway is 56 miles per hour with a standard deviation of 4 miles per hour. Okay, these are important, right? You measure the speeds of 3 cars traveling along this stretch of highway as 62. Ooh, one of the cars is going 62 miles an hour. One of the cars is going 47, and one is 56. Find how far off the z-score that corresponds to each speed and assume that the distribution of the speeds is approximately bell-shaped. So we're going to take this little formula. We're going to, okay, for the first one we're going to look at 62. So we're going to do 62 minus the average. What was the average again? Oh yeah, 56. So 62 minus 56 and then divide it by the standard deviation of 4. So for 62 miles, 62 minus 56, get an answer, then divide by 4, you get 1.5. So it's 1.5 standard deviations away from the mean. So it's not, that's not very close. It's not very far, but that's what it is. So then if we look at 47, we do the same idea. 47 minus the average, get that answer, and then divide by the standard deviation. So 47 minus 56, hit enter if you're using a scientific calculator on your phone. Hit enter before you divide, and that's saying negative 2.25. So this person was going 1.5 standard deviations above the average. This person was going 2.25 standard deviations below. That's what the negative means. They were going slower, right? And then the person going 56 miles per hour was going the exact average. So there's no standard deviation. They are doing the same as the mean. So there's no change, right? They're not off at all from the mean. And we can only do these things if we know it's bell shaped, AKA normal distribution. Okay. All right. So next one, comparing z-scores from different data sets. So this time we're talking about men's height and women's height. And we've got the means and the standard deviations. And it says compare the z-scores for a 6-foot tall man and a 6-foot tall woman. All right. So we're going to talk about 6-foot tall man and woman. We want to know how far off are they from the mean of these heights. Assume it's approximately bell shaped. All right, so to do this, first we have to think this stuff is in inches. How many inches is 6 feet? Okay, well, 6 times 12 feet is 72 inches. And you know what? Let's do ladies first. I always talk about the men first. Let's do ladies first. So let's compare a 6-foot tall woman compared to the average 64.3. So we take that z-score and we do 6 foot tall was 72 inches. So 72 minus 64.3 and divide it by the standard deviation for women. We get that's 3 standard deviations off. Whoa, 3 standard deviations. We said before that 2 standard deviations would make something unusual and 3 would make it very unusual. So a 6-foot tall woman, according to this data, is very unusual. 3 is pretty big standard deviations. All right, now let's compare the dudes. 6-foot tall man compared to their data. So we're going to do 72 inches again because 6 feet is 72 minus 69.9 and then divide it by 3 for the men. That gives us 0.7. That is not very different than the average, right? And that makes sense. 72 is not very far off from 69.9. Okay, so this is a way to use 2 different sets of data and compare them. The same height in this 2 sets of data gives 2 separate z-scores. Because for women, that's a big difference. To be 6 feet tall, it's very, very unusual. And for men, that's pretty run-of-the-mill average according to this data. Pretty close to the average. So your plan is to go ahead and keep working on Math Excel 2.5. And we are going to have a Chapter 2 test next week. This is the last section for this Chapter 2. So you're going to want to start getting together your notes, and we're going to do some reviews the next couple days. And then to make sure that you're ready for your test on Monday. Next week. Okay, bye.